step for man, one giant leap for mankind.
Tonight, we celebrate the 40th anniversary of the first footsteps on the moon. We discover the truth about the moon's dusty surface.
It's little boxes like this that are telling us the secrets of moon dust.
The dark side of the moon offers up its secrets.
Finding other planets like Earth, and you don't have to leave home.
And I ask why scientists are still so interested in the moon. G'day, welcome to Catalyst. It was exactly 40 years ago today that Apollo 11 took off, taking Neil Armstrong, Buzz Aldrin and Michael Collins on that extraordinary extraterrestrial journey. I know I was certainly glued to the old black and white telly back then. In fact, I wagged school for the day to make sure I didn't miss a single second. Apologies to the teacher now, but I did at least end up becoming an astrophysicist. Apollo 11 was surely one of humanity's finest achievements. Let's remind ourselves.
Stop. APA at a descent. Mode control, both autos need to land. Command override off. Engine arm off. Tranquility Base here. The Eagle has landed.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
Yeah, I just checked. Getting back up to that first step. That's one small step for man. One giant leap for mankind. That's beautiful, man. It has a stark beauty all its own. TV picture now, Houston.
Eagle Houston, you're looking good at 2. Ping, zags, and misspin, all agree.
There we go.
Set. I was strolling on the moon one day. In a merry month of December. No, May, that's right.
This was the antenna, originally at Honeysuckle Creek, that relayed Neil Armstrong's first steps on the moon to televisions all around the world. And the deputy director of Honeysuckle Creek at the time was Mike Dinn. G'day.
Hi.
Now, most people think that Parkes played the biggest role for the Apollo missions, but that's not true.
Well, that's not completely accurate. That very first step on Apollo 11, where Armstrong came down the ladder and stepped onto the moon, came through this antenna here at the Honeysuckle Creek tracking station, which was a few miles south of here. That was the era of analog equipment, where things could be tuned, manipulated. It had switches and meters and dials and oscilloscopes and knobs to twiddle. However, it did take about, 25 people to operate all that equipment, whereas today, at Tippy Miller, they can do it with one person.
This is Honeysuckle Creek on the day of the moon landing. The then Prime Minister, John Gorton, was doing the official tour.
I asked them what all the little wiggly green lines were and what the various noises coming out of bits and pieces of the equipment were, and got answers which I wouldn't pretend thoroughly to understand.
Honeysuckle Creek was the key tracking station in our part of the world, a vital link when the Earth's rotation took other tracking stations out of sight of Apollo 11. We also had Carnarvon in Western Australia, a tracking station which employed even more people than Honeysuckle Creek. and created huge excitement in this small town.
There are few moments in a man's life of supreme tenseness and excitement.
This sort of thing was beyond one's imagination. It was Jules Verne. It isn't Jules Verne anymore.
It was Carnarvon's job to communicate with Apollo 11 while it was still in Earth orbit. And the technology to do that hadn't been seen in these parts before.
This is Apollo control. Inside, it's almost deceptive in its cold-blooded, antiseptic, machine-dominated atmosphere. In fact, so developed is the machinery that it's said that the computers here talk to computers in Houston.
The computers did indeed talk to each other, and Australia played a vital role in the Apollo 11 landing. One of the biggest questions about the moon before we went there is, what is it made of? Are its plains vast seas of dust? Are they lava outflows? Well, the answer finally came when we got pieces of moon rock back here on Earth. And here's one now. In fact, one of the biggest on display anywhere in the world. One of the first scientists to get his hands on the moon rocks was Melbourne University professor John Lovering. Hello.
G'day, Graham.
Doesn't look like green cheese.
No, it doesn't, but it's the most wonderful thing to see. When I first saw it, I was blown over. Just to see it was fantastic.
Looks like something that came out of a volcano.
Well, it did. Well, not necessarily a volcanic peak, but it was a great lava flow. And it has all the characteristics of a lava on Earth. It has vesicles, that is, gas cavities in it. It looks just like a piece of Melbourne basalt.
I hear there's a bit of a story about how you got these moon rocks back to Australia.
Yeah, I went over to pick it up and first of all to go into the lab and see the samples just after they'd arrived, which was very exciting. And then I came back with the samples sitting in a bag on my lap all the way.
You didn't let it go at all?
Never did. Even when I went to the toilet, I kept that bag with me.
Making a journey to the moon requires overcoming all sorts of potential problems. But one that was underestimated was dust. This is the official NASA simulated moon dust. And it turns out it is incredibly fine and much more dangerous than previously realised. And that was discovered by an Australian, as Paul Willis reports.
If you were alive on the 21st of July 1969...
I am the greatest!
...you'll probably remember exactly where you were. I was a 5-and-a-half-year-old schoolboy on the other side of the planet back in England, and I was being hustled into the school canteen, where the only television was, to watch this.
It's one small step for man.
But people forget what Neil Armstrong said just a few seconds before.
Although the surface appears to be very, very fine-grained as you get close to it. It's almost like a powder.
That was the first direct geological observation made of the moon, and it was about dust. Even before we got there, some people were worried that moon dust would scupper the whole mission.
Ranging from Isaac Asimov's thought that spacecraft would sink majestically out of sight, to people who just thought it might be a creepy, crawly problem, electrostatic dust.
So, which of the astronauts did you work with in the Apollo missions? In the late 1960s, Brian O'Brien was Professor of Physics at Rice University in Texas.
Beautiful white radiation experiment.
He had a particular interest in the Apollo missions. They were carrying his experiments. He designed this package called CLEAP to measure charged particles on the moon. But he realised that dust from the moon might interfere with his delicate instruments.
So I invented a dust detector.
And that's this little box over here?
That's a real-size model.
Despite the initial fears from some people about what a menace moon dust might prove to be, 4 of these little boxes would be the only experiments taken to the moon to measure moon dust.
Apollo 11, Apollo 12, Apollo 14, Apollo 15 all had a dust detector. Apollo 13 had a dust detector, but that, of course, burnt up in the atmosphere.
Lunar dust is extremely fine, the product of billions of years of impacts from meteorites and radiation. It has the consistency of talcum powder.
The dust stuck to everything. When they actually walked on the moon, it stuck to their spacesuits. It really was just a total nuisance and a hazard on occasions.
Let's fast forward 35 years to the mid-2000s. The USA want to return to the moon and establish a permanently manned base there. Time to dust off Brian's tapes recording moon dust.
So I telephoned NASA and they said, "Yea, verily, we have misplaced the tapes. We would love to have yours."
This is one of Brian's data tapes. The other 172 of them are in this pile of boxes here. They contain a unique record of dust on the moon from 3 Apollo landing sites for a period of up to 6 years. It's a unique and remarkable archive. The trouble is, no one can read them.
How many more of these do you have to do?
There's a lot to do.
Fair enough.
Guy Holmes heads up Spectrum Data, the company that now houses this precious moon dust archive.
It's really a late 50s, early 60s type of technology. There was one manufacturer, basically the pioneers of magnetic recording.
Guy and his assistant searched the world for one of these, an IBM 729. In the early 1960s, this was the bee's knees in computer data tape drives. Today, it's as rare as rocking horse teeth. They found this one in Sydney, and their next trick is to get it working again. Even if they get it working again, the 40-year-old tapes may be too fragile to withstand being read by the 729. But Guy is optimistic.
We're very confident we'll be able to read them all. But we'd certainly like to see the whole project finish this year in 2009.
Until a way is found to read the data on these tapes, the secret life of dust on the moon will remain a mystery to us.
Number 3 is...
Well, mostly.
We can't read the computer tapes, but fortunately in 1969 and 70, I got the computers at Harry Messel's School of Physics to make me about 100 plots of what was on the tapes.
These bits of paper gave Brian access to less than 1% of the raw data stored on those tapes. What he found was astounding.
The stickiness of the dust varies depending upon the time of day. As the sun comes up and gets brighter and brighter, fuller and fuller in the sky, the stickiness increases.
This is shocking news for the future. All the Apollo missions occurred in the lunar morning of a 700-hour-long lunar day. No one has experienced a lunar afternoon.
If the astronauts stay during the full day, for the middle part of the day, dust will be much more of a problem, much stickier.
Clearly, there's a lot more to the moon dust story than anyone thought possible all those years ago, when mankind first set foot on the moon.
Even though it's been 40 years since those first famous footsteps, scientists are more excited than ever about the moon and are just itching for us to get back there. One of the things they want to do is take a closer look at the moon's craters. They hold all sorts of clues about the evolution of the solar system and even about the beginnings of life on Earth.
The moon has witnessed most of Earth's history, silently from space. It looked on as life began on our planet around 4 billion years ago. And vital clues about this Genesis moment were recorded in the moon's multitude of craters.
When you look at the moon, you'll see crater, crater, crater. Everywhere on the moon there are craters. But on Earth, we look around, there are no craters, and that's because there's water flowing, there's erosion, there's wind on the Earth, but not on the moon.
All but the most recent craters here have been worn away, so we don't know a key aspect of the Earth's environment when life was beginning: how frequently our planet was being bombarded from space. But the Moon was in the same path of colliding debris and doesn't suffer erosion.
The Moon is a record of the bombardment history of the Earth. The Moon is like the Earth's attic. If we want to know what happened a long time ago, early in the Earth's history, we should look at the Moon.
The reason bombardment and early life are connected is because the planets and moons formed through collisions. Smaller bodies crashing to make bigger ones. And the impacts continued for a while, even after the Earth had formed.
There was still a lot of things bombarding you. Boom, boom. There was a heavy bombardment. And I guess if life has to get started, it has to get started in between those really big impacts.
Other theories have it that the impacts may have even got life going.
In the early days of the solar system, the sun was much weaker than it is now. So according to one theory, the Earth would have been covered by glaciers back then. So a big downpour of space rocks would have melted the ice and created some nice, warm, watery environments for life to get going in.
The problem is, there are a lot of theories and very little evidence. We need to go back to the Moon to gather more data. Specifically, we need to accurately date the Moon's craters, so astrobiologists can better know the Earth's bombardment history. At the moment, the Moon's basins and craters are mainly dated by observation and counting.
The new crater looks something like this. This is Copernicus, and you can see that, first of all, that it has streaked all across the surface of the Moon.
That's the debris, the impact.
That's the debris that's got spread all over the place. This one, too, is rather new, very new. And anytime you can see a crater with these streaks, that's new. Also, if you look here, you will not find any impact craters, or very, very, very few, inside of this new crater. So that tells us, it's young. If you look, for example, at this crater here, look at that. There are all kinds of craters inside of it and all around it and breaking up the rim. And so that would be much, much older. So this would be, 500 million, maybe even 1 billion years old. And this would be 3 or 4 billion years old.
So you can date the basin by counting the number of craters within the basin.
We can get a relative date. We can say this is younger than that.
To get an actual absolute date, you need rock samples from the Moon. And that's one of the key reasons astrobiologists want us to go back, to visit a crater so big it's known as the hole at the bottom of the Moon.
The biggest and oldest crater that we know of on the Moon is on the far side, near the South Pole. It's called South Pole Aitken. We know it's the oldest because it has the largest density of craters inside of it. And plus it's gigantic, and it's really deep as well.
If a future mission can date this crater, scientists will be able to work out absolute dates for many of the younger craters. Then they'd know the timing of the impacts and could narrow down the theories on how life began on Earth.
Many of us wonder if there's life elsewhere in the universe, if there are other Earths orbiting distant stars. But what would one of these planets look like when viewed from afar? Well, a way to find out is to look at the sunlight reflected off the Earth and onto the Moon. It's called Earthshine, and a University of Melbourne PhD student is doing just that. One day, her work could lead to the detection of other planets with continents and oceans just like ours.
More than 40 years of space exploration have changed forever how we perceive our home planet. One of the first photos of Earth taken by an astronaut showed it rising above an alien horizon. 2 decades later, the view came from a camera at the edge of our solar system. That pixel of light is the Earth.
I want to know that we're not alone, that there's a chance of something like us being out there.
If there are other pale blue dots in the galaxy supporting life like our own, how do we know what to look for?
Our research will help when we find Earth-like planets in the right region to have liquid water, that we will be able to tell if they have liquid water and land masses, so they might have the potential to hold life.
Astronomers have now found more than 350 extrasolar planets, that is, planets orbiting a star other than our Sun. Many are gas giants, a bit like Jupiter, but so far none are anything like Earth.
We're really using the Earth as the model for a planet far, far away, but it's very hard to look at ourselves while standing on the surface.
You don't have to travel right across the solar system to figure out what a watery Earth looks like from outer space. The clues can be found a lot closer than you think. In the shadows of the crescent moon.
You can use the moon to look at the reflection of the light, and this is like looking at Earth as if it was in another solar system.
A few nights every month, for 3 years, Sally Langford trained her 8-inch telescope on the moon and attached a CCD camera to measure Earthshine.
Earthshine is sunlight that's reflected off of Earth that lights up the part of the moon not lit directly by the sun. So the part that's not the crescent, it's the darker part that has a sort of ashen glow that you'll see. So you can just see it through the viewfinder there?
Yeah, it's just fantastic, isn't it? What are the perfect conditions for seeing Earthshine on the moon?
The moon has to be a couple of days just before or just after the new moon, so you can see when there's just a crescent and you can actually see the outline of the rest of the moon. We actually focus just a small region and take literally digital photos. And so from that you get counts of light and we can then process that later on. So we bring the images from the camera straight into the laptop.
What have we got?
So I'll show you an example.
Wow.
So you can see
That's
here
incredible.
the two different images. What's amazing is that this is actually the Earthshine part. So this is the darker part of the moon.
That's the dark side of the moon.
That's the dark side of the moon. And this is the bright crescent. And so this was taken with about 10 seconds. So you can see that it actually gets right, whereas this is 6/100ths of a second. So you can see how they're very, very different brightnesses.
In the flicker of light from Earth is the key to recognising the glint of distant starlight from an extrasolar planet like our own.
We can actually take images of the Earthshine over a couple of hours and see up to a 20% difference in the amount of light that we measure on those images
20%?
per hour. Yes. We had an idea that it would be variable on the Earth's surface, but no one's actually used Earthshine to measure that difference from ocean to land across a coastal crossing.
Now, if this is the moon, show me how Earthshine works.
So if this represents the Earth, and we have two different types of surfaces, we have black representing the land and white representing the ocean.
Fair enough.
We also have our light source over there, which is like the sun.
Yep.
So when the sunlight comes in and hits the land, it lights up the moon and you can see Earthshine.
Sure.
So then as the Earth rotates and ocean comes into view, you can see how the Earthshine brightens.
And then you can measure that with a light meter.
Exactly. So then as we rotate the Earth and the land comes into view, the Earthshine dims and you can measure that.
Sally recorded 7 data sets. One, when the Earthshine is reflected completely from the ocean.
So you're going to have that bright spot and it's going to stay there the whole time. So if you have a look at those results, you can see that the change in Earthshine with time, it's very flat.
Yeah, hardly any change at all, just a flat line.
Exactly. And each of these boxes shows the central point of reflection for each of these points that we measured.
So what you've done is you're able to relate the bright spot you see on the moon to where on the surface of the Earth it's coming from.
That's true. So if we then have a look at what happens when the bottom tip of Africa rotates into view and blocks that bright spot, and you can see that the change in Earthshine with time is quite a significant
That's
decrease.
a dramatic difference.
Yes. When we're over the ocean, it's a lot brighter than when we're over the land.
And that accounts for about 20% difference.
Yep, that's our largest decrease that we measured.
The moon is a mirror for how Earth appears from space. A telescope on a space probe recorded these remarkable images 50 million kilometres away. And there is the sun glint, just as Sally has tracked in the Earthshine reflected from the moon. And she didn't have to leave home.
In the future, if we are able to find Earth-like planets, the same sort of size, that might have liquid water, then we can actually watch them as they rotate. And if they get brighter and dimmer, then there might be land masses and oceans.
Just like Earth.
Just like Earth. I would love to go into space, but there are still some backyard astronomy projects that can tell you a lot about the world.
Well, that's it for this week and for the next few weeks, in fact. While an exciting new 5-part series called Whatever, The Science of Teens, runs on Thursday nights.
Whatever.
Today's teens are portrayed as moody, lazy, oversexed, binge-drinking risk-takers. Through a range of experiments, we'll get inside the teenage brain and show you what's up with the whatevers.
In the meantime, don't forget our website. In fact, check out the lunar extras. There's links to incredible high-definition images taken from a Japanese satellite of the surface of the moon. I'll see you later.